So in this video, we will apply first law of thermodynamics to a flow process. Until now, we used first law. We applied first law for a system. Only now we are applying the first law of thermodynamics in a flow process. So what exactly is a flow process? A flow process in which, see, there is a mass flow. If you take this open system, there is a mass coming in and there is a mass going out. That is why this is called a flow process. Okay, so this is an open system. So we are applying the first law for an open system or a control volume. So this is the control volume you are taking. And so these turbines, compressors, etc. all these come under the category of these open systems. So you can apply only this equation for those processes. So let Q be the heat supplied, Q dot be the heat supplied, and W is the work produced from that device. For a turbine, it produces work. Okay, for a compressor, that means you are supplying work. Okay, for a boiler, you are supplying heat. Okay, you are not getting a work, but you are supplying heat. Okay, so again, when you apply the first law to this flow process, you know that E dot in is equal to E dot in. That is energy coming in per second minus energy coming in going out per second is equal to d by dt of E system, energy of the system. Uh, so E dot in, so E in is equal to, you can write E dot in is equal to that is total energy coming in per second. E dot in is equal to Q dot plus that is the energy supplied in the form of heat plus m1 dot, because this mass has got an energy, so it carries an energy in, so it carries an energy because this mass has got an internal energy U, and this pressure volume, that is the pressure energy, that is P1 V1, or the flow work, this is the flow work, plus it has got a kinetic energy, and it may have got a potential energy also. So the total energy coming in is Q dot plus energy carried by this fluid. Okay, so E out, energy going out, is equal to, so E dot out is equal to W dot plus M2 dot into, so this is the, so energy going out, that is E dot out, is equal to, see, you can see that if it is doing a work, then energy is transferred outside, plus this fluid that is going out is carrying an energy that is equal to, it has got an internal energy, flow work, kinetic energy, and potential energy. So E dot out is equal to W dot plus M1 dot M2 dot into U2 plus P2 V2 plus V2 square by 2G plus GZ2. So we have found E dot in and E dot out. Now you can apply these two here. This is your energy equation, law of conservation of energy equation. That means total energy coming in per second minus total energy going out per second is equal to rate of change of energy of the system, d by dt of E system. So if you take this now, uh, what is a steady flow device? So before applying that equation, let us know what is a steady flow device. So we have seen a flow process, and so what do you mean by steady flow device? Steady flow device means E dot in will be equal to E dot out. That means d by dt of energy system is 0. That means there is no change in energy of the system with respect to it will remain constant. That means whatever energy coming in is going out. So, and also dm by dt of the system is 0. So there is no mass change to the system. So almost every property of the system remains same with respect to time. So m dot in is equal to m dot out. Okay, so this is m dot in. Now that means m dot 1. If you take this as inlet and this as outlet, so m dot 1 is equal to m dot 2 is equal to m dot. So we will use these terms in the equation. So that means, so we have found that E dot in is equal to Q dot plus M1 dot into this term, and also E dot out is equal to this is equal to W dot plus these terms, M2 dot U2 plus P2 V2 plus V2 square by 2G plus GZ. Okay, so and this is our steady flow energy equation, because U1 plus P1 V1 is equal to enthalpy. Okay, so here also U2 plus P2 V2 is your enthalpy H2. So this equation is called the steady flow energy equation. So you can simplify it and write like this. So this is your steady flow energy equation, or you will call it SFEE. Okay, so this equation can be applied only for a steady flow device, not to any flow device, but only for a